In this section, we're going to step away from Vue for a moment. If you're interested in creating small widgets for your site, you've learned everything you need to know. Loading Vue with script tags will suffice for small widget projects. However, if you're looking to build full scalable web applications, there's still much more to learn. It's possible to make apps by loading Vue through a script tag, but it's not the most efficient way. You will want to use the proper tools to help you with debugging and scaling the application. That's where we're headed next. The development team for Vue has curated a set of tools for building Vue applications. These tools are built on top of other tools. They'll help us face challenges such as optimizing bundles, code splitting, and managing assets. In this section, I want to discuss the tools Vue uses under the hood to make our lives easier. While it's not completely necessary to know the underlying tools, it may help you in future projects. A lot of job postings require that you have some basic understanding of the tools. You don't have to be a pro. The fundamentals of each tool are enough to get you started. Keep in mind that Vue takes care of many more technical and challenging parts for you. The goal of Vue is to simplify the development experience. You don't need to stress over every detail. Here are the following tools we will be reviewing in this section: Vite, Webpack, Babel, PostCSS, Sass, and ESLint. These are the primary libraries we'll be dealing with in most advanced projects. I want to stress that if you're already familiar with these tools, you may skip this section. I'm not going to be teaching anything groundbreaking or new about these tools. My main goal is to give an overview of what these tools are and how to use them. We won't be able to dive deep into these tools, as it would take up too much time. Before you proceed with this section, there are a couple of things you should know. You should have some knowledge of ES6, things like arrow functions, constants, modules, etc. We will be using modern JavaScript to build our applications. If you're ready, I'll see you in the next one. In this lecture, we are going to get started with Vite. Vite is going to bring everything together. It's one of the newest packages to enter the JavaScript ecosystem. Despite that, it's already gained a considerable following. Hundreds of thousands of developers are integrating Vite into their workflow. So, what is Vite? Vite is a module bundler for applications. During the development process of your app, you're going to be creating dozens of files. They can range from JavaScript files to images. Once you're ready to push an app into production, you may want to optimize, compress, and minify your codebase. For example, let's say you had 20 JavaScript files in a project. As we know, it's considered good practice to split your code into separate files for manageability, but the user shouldn't be forced to download dozens of files. Ideally, they should download as few files as possible. That's what Vite is for. It'll compact your project into as few files as possible. However, it can do so much more. Vite is not the only tool that accomplishes this task. If you do your research, you may come across other module bundlers such as Webpack, Parcel, Snowpack, or Rollup. Currently, Webpack is considered the industry standard. So, why are we going to use Vite? Performance is highly critical for development. Webpack is starting to show its age. As your project grows, bundling a project can take longer. Makes sense, right? Bundling hundreds of files can take a while. Unfortunately, most tools struggle with bundling large projects. Vite does not have this problem. You can always expect a project to bundle within seconds. Another advantage of Vite is its immense support for third-party libraries. A lot of bundling tools focus on JavaScript. Support for images, CSS, or other file types requires plugins. It's up to developers to add support for different types of files. Out of the box, Vite supports the most popular tools for front-end development, from TypeScript to Sass. This feature allows developers to focus on their projects rather than configuring a set of tools. This leads me to my next point. You may need a specific tool to be supported in your project. If Vite does not support it out of the box, that's perfectly fine. Vite is easily extendable. You can add support for other tools by updating the default configuration. In my opinion, configuring Vite is easier than configuring other tools. For these reasons, Vite is gaining traction among the community. It wouldn't surprise me if it became an industry standard within the next few years. Best of all, the creator of Vite is the creator of Vue. Both packages are easy to integrate together. Let's try creating a project with Vite. This process is straightforward. It's not recommended to create a project from scratch. Instead, the Vite package has a tool for quickly scaffolding a project. In your editor, open the command line. I highly recommend pointing your editor in an empty directory. We do not want the files generated by Vite to conflict with existing files. Inside the command line, type the following command: npm create vite at latest. The npm create command will initialize a package's executable. After this command, we must provide the name of the package. In this case, we're trying to run the Vite package. Let's run the command. After doing so, npm may ask us to confirm our decision to run this command. It can be dangerous to execute a package straight away. We can safely run this package. Let's proceed with the installation. Up next, Vite will ask us a few questions about our project. Firstly, it'll ask us for the project name. You can freely change the name. For our example, let's stick with the default name. After setting a name, we can select a framework. Vite is compatible with most JavaScript frameworks. It's not a tool exclusive to Vue. Even though we're learning Vue, we're not going to select it from the list. Instead, let's stick with the vanilla option. The reason is simple. The main objective of this section is to focus on Vite, not Vue. After we have a good understanding of Vite, we'll look into integrating both packages. The vanilla option will create a project with plain JavaScript. No frameworks will be installed. We have the option of using TypeScript. However, I think plain JavaScript works best. After selecting our options, a new directory has been created with the same name as our project. In addition, the Vite package will provide a list of additional commands to run. Let's move into the directory with the cd command. Next, let's install the packages with the npm install command. This process may take a while. Once the packages are finished installing, let's talk about the files and directories in the next lecture. I'll see you there. In this lecture, we are going to explore the project scaffolded by the Vite package. Before getting started, you should point your editor to the directory created by the package. It'll be easier to inspect and run commands from this directory. Pause the video if you need. Once you've got that sorted, let's begin. In the root directory of the project, there are a few files. The most important file is the index.html file. This file is considered the entry point of our application. What is an entry point? The entry point refers to the file responsible for launching an application. The entry file can import other files from images to JavaScript files. This step is important to highlight. If the entry file does not import other files, it's possible that they may not get bundled with our project. If we look closely at the HTML file, two files are being imported. They're the favicon and script files. However, our CSS file is nowhere in sight. In the project, a basic CSS file was created. Despite not being imported from the main HTML file, it will get bundled with our project. To find out why, open the main.js file. The very first line of code in this file is an import statement for the CSS file. Typically, import statements for CSS files are not supported. The JavaScript language does not allow this behavior. By using Vite, CSS imports are allowed from within a JavaScript file. During the bundle phase, the CSS will be extracted into a separate file. The CSS will not be embedded into our script file. We do not need to worry about bloat. Not all dependencies need to be imported into the entry file. Since the script file is imported into the HTML file, our script is allowed to import additional files. There isn't a limit as to how many files can be imported. Let's try running our project. Open the package file. Overall, the package is very simple. There's nothing abnormal about it other than the script's object. From the beginning, We're given 3 commands for running our project. The first command is called dev. This command will launch a server for development. You may not want to constantly manually build your project. The dev command will force the server to watch your files for changes. If a file changes, the build will reflect those changes. The process is completely automated. Let's give it a try. Open the command line. I recommend moving the command line into a separate tab. I find it easier to read the command line as a tab as opposed to a separate panel. You can drag and drop the terminal by its name. After moving the terminal, let's run the npm run dev command. After a few moments, the package will create a temporary server for viewing our application. Let's visit this URL in our browsers. Voila! We've got a fully functional development environment. We can start working on our project. As we do so, the package will refresh the page during updates. Let's head back to the command line to explore the other commands. The next command in the package file is called build. Unlike the dev command, the build command will build our project once. If we look in our projects directory, nothing has changed. What if we want to grab the final bundle? The build command will output the files for us. Let's give it a try. Back in the command line, you may need to exit the current command. By launching the server, Vite does not allow us to run additional commands. In the command line, run the npm run build command. In a few moments, the command will produce a bundle in a directory called distribution. We can check out this folder for the final output. These files can be uploaded to a server for production. You do not need to include files outside of this directory. As I mentioned before, only files imported directly or indirectly from the entry point file will be included. In the assets directory, we will find the CSS file. What if we removed the import statement for this file? Let's find out. In the main.js file, remove the import statement. Next, run the npm run build command. If we look at the distribution/assets directory, the CSS file is missing. Since our app is not importing CSS, this file is not included with the bundle. Before uploading our project to production, we may want to verify that the app is fully functional. However, we can't because the server is not running. In the command line, we can run the npm run preview command to launch the server for the distribution directory. The preview and dev commands are similar. There's one huge difference. The preview command does not watch our files for changes. The purpose of the preview command is to launch a server for the build directory. It allows us to quickly inspect the final build. The dev command is for the development phase of a project. Now that we have an overview of our project, let's start exploring some of the features of other tools. Along the way, we'll learn more about Vite. When you're ready, I'll see you in the following lecture. In this lecture, we are going to start exploring a second tool called Sass. This lecture will be a brief overview of the language. Sass is a topic that deserves a course of its own. I encourage you to look at other courses or tutorials to learn more about Sass. In the resource section of this lecture, I provide a link to the official site for Sass. Sass is a programming language for CSS. CSS is not known for being an intelligent language. Features like functions or conditional statements are non-existent in CSS. Sass was introduced for extending CSS. We can perform various actions, from defining functions to looping through an array of data. Sass is an extremely powerful language. However, Sass is not supported in the browser. It must be compiled into CSS. Luckily, there's a package for handling this process. In your editor, open the command line. Let's install the Sass package with the following command: npm install Sass. Out of the box, Vite supports Sass. We do not need to configure Sass. This means we can start writing Sass right away. In the previous lecture, we removed the import statement for our CSS file. Rather than importing a CSS file, let's import a Sass file. In the project, rename the style.css file by changing its extension to scss. The extension for writing Sass is scss. Next, let's open the main.js file. At the top of the file, import the main.scss file. Next, let's launch the server. In the command line, run the npm run dev command. For the rest of this section, you should always have this command running. Let's check out the app in the browser. As you can see, the styles are being applied to our elements. Otherwise, the text would not be centered. Vite was able to import the Sass file, compile it, and include it with the bundle. We can prove this behavior by opening the Elements panel with the developer tools. Search for a style tag in the head section of the document. If you know CSS, you already know Sass. Sass supports all CSS features from selectors to variables. It does not attempt to override the language. It simply extends it. Head back to the editor. In the Sass file, let's start exploring some of the cool features that Sass has to offer. The first feature is functions. It's common to apply color effects to an element during an event. For example, if a visitor hovers their mouse over an element, the color might change. Let's give that a try. Add an H1 selector. Set the color property to the following value, #cc3244. Next, add another selector called H1 hover. The value for the color property will be a function called darken. The darken function is not available in CSS. It's defined by the Sass language. This function will return a new color with a darker shade. Functions are written similarly to JavaScript functions. It's the name followed by a pair of parentheses. It has two arguments, which are the color and the percentage. Let's pass in the same color as before, which was #cc3244. The second argument is a percentage value. The higher the value, the darker the color. Typically, I like to use any value between 5 and 15%. Let's use 15%. Switch over to the browser. You shouldn't have to refresh the page. Vite will automatically reload the page for you during updates. If we look at the heading, the color is red. We can hover our mouse over the color to view the new color. As you can see, we do not need to calculate a darker color ourselves. Sass is capable of picking a color for us. In the resource section of this lecture, I provide a link to the list of functions you can use to change colors. Admittedly, the official documentation isn't that easy to read or navigate. I encourage you to take your time with it and experiment with some of them. Alright, let's continue exploring other features. Another cool feature of Sass is nesting. Head back to the editor. Switch over to the main.js file. Let's wrap the word Vite with a pair of span tags. It's not uncommon to style nested elements. Back in the CSS file, we can change the color of the span element by creating a selector called H1 span. With Sass, we can take a different approach. Instead of typing this selector, we can add the span selector from within the H1 selector. Nested selectors are allowed. During compilation, the selector will be transformed into H1 span. Initially, this syntax may look weird, but there are two benefits to this feature. Firstly, the precedence in CSS becomes clearer. When your code is formatted like this, it can be easier to see which CSS properties will dominate others. The second benefit is that you won't end up repeating the same selectors since it's easier to tell where you've written them. Inside the span tag, change the color property to blue. In some cases, you may need to reference the parent selector. A perfect example of this scenario would be the hover pseudo-selector. We could nest this selector inside the H1 selector like so. However, this solution won't completely work. This selector will produce a weird selector. It would be transformed into H1, H1, hover. We don't want this. We want the same selector we had before. Sass provides a selector called the ampersand selector. Replace the H1 selector with the ampersand symbol. The ampersand symbol will represent the parent selector. Sass will replace this symbol with the parent selector. This will result in the selector being H1, hover. Let's try testing our code by switching to the browser. The span tag content will be the color blue. We can hover over this element to change the color to a darker color. Great! We've successfully learned another feature of Sass. Sass is a great language. It's definitely worth learning. I encourage you to play around with it and see what you can do. A single lecture doesn't do it justice, but it should suffice for now. Before I end things, I want to say that you don't have to be a master of Sass. We won't be using it heavily in this course. Just because Vite supports a tool doesn't mean you're forced to use it. We'll be focusing mostly on Vue, but it's always good to know what Sass is and how it works. In this lecture, we are going to move on to another package called PostCSS. Sass is a dominant language in the development world for extending CSS. As the years go by, it's starting to lose popularity. Another package was introduced called PostCSS. It takes an entirely different approach from Sass. You can use PostCSS over Sass, or a combination of both. Before getting into PostCSS, let's talk about how Sass works. Sass is a preprocessor language because it's a language that gets compiled into CSS. It's because browsers don't understand Sass code. There are dozens of preprocessor languages available, like Less or Stylus. In the end, they all get compiled to CSS. PostCSS takes a different approach. It is not a language. There is no special file extension. Instead, it's a library written in JavaScript. It'll convert your CSS into an object. The object it generates can be manipulated and transformed with JavaScript. Once you've made your changes, the object will be compiled into CSS. The advantage here is that we can use JavaScript to interact with our CSS code. This is why it's called PostCSS. It is a library that can modify your CSS code after you've written it. PostCSS is popular within the Vite and Vue community. Unlike Sass, we do not need to install the PostCSS package, nor do we need to configure this package. It's installed and configured by Vite. This feature gets activated by creating a specific file in our project. In the root directory of our project, create a file called postcss.config.js. PostCSS will search for this file. If it finds this file, it'll load the configuration settings. Inside this file, we must export an object. The object will contain our configuration settings. There are several things we can do, but we'll keep it simple. By default, PostCSS does not apply changes to your CSS. You must install plugins for manipulating the output of your CSS. There are two options at our disposal. Firstly, we can install plugins from third-party developers. Secondly, we can develop custom plugins. For this demonstration, we are going to use a third-party plugin. Vendor prefixes are an important feature of CSS. They allow us to use experimental features in our CSS. However, we may forget to use a vendor prefix. There's a plugin for automatically applying vendor prefixes to your CSS code. There's a vast repository of plugins available. In the resource section of this lecture, I provide a link to a site called PostCSS Parts. This site provides a list of plugins from the community. I highly recommend bookmarking it if you plan on using PostCSS in future projects. Let's switch back to the editor. Inside the command line, input the following command: npm install autoprefixer save-dev. This module is a plugin for PostCSS. It'll scan our CSS properties for missing vendors. It'll add vendor prefixes to properties that require a vendor prefix for older browsers. After installing this plugin, we must load it from within the configuration file. In the configuration file for PostCSS, we'll add a property called plugins. Its value will be an array. Inside this array, we can load a plugin by calling the require function. This function accepts the name of the package to load. Let's pass in autoprefixer. Great! The plugin should get loaded into our workflow. To test our code, let's update our CSS. Open the style.scss code. PostCSS does not work with Sass. Luckily, Vite will process Sass first. After the Sass file has been compiled into CSS, the CSS will be passed on to PostCSS. It's perfectly fine to continue using Sass. Alternatively, you can switch back to CSS and remove Sass from your workflow. Either option is at your disposal. Inside this file, let's add a selector called : placeholder. Next, change the color property to red. The placeholder selector will allow us to manipulate the properties of an input's placeholder. Developers will add this selector to change the color of the element. This selector has a prefix for Firefox. What if we forget to add the prefix for this browser? No problem. The autoprefixer plugin will add it for us. Let's save our file. Next, we may need to restart the server. Otherwise, the plugin may not be applied to our project. In the command line, restart the npm run dev command. So far, we shouldn't receive errors. Let's view the application in the browser. Nothing has changed. In the developer tools, open the Elements panel. Search for the style tag in the head section of the document. The placeholder selector was duplicated. The second copy of this selector has the Mozilla prefixer applied to it. That's great. We never have to worry about forgetting to add a prefix to our CSS. In addition, we can purposely leave out prefixes from the original codebase. It'll keep our code clean. PostCSS can handle adding the prefixes during compilation. That's all there is to PostCSS. It's a tool you can configure with plugins to transform the output of your CSS. In this lecture, we are going to explore a tool called ESLint. Code quality is an important part of development. We should always be consistent and error-free. JavaScript is a great language, but it does not enforce strict rules for formatting our code. For example, open the main.js file. Inside this file, we're using single quotes. Let's say our team wants to use double quotes. From time to time, we may forget to use double quotes in a file. It's not uncommon for developers to be inconsistent with their formatting. JavaScript will not complain. As far as JavaScript is concerned, everything in the file is valid. This is where ESLint joins the picture. It'll enforce stricter standards in our code. We can create a set of rules to apply to our code base. If we break a rule, we'll be informed by ESLint. We can catch problems that normally won't be caught by an environment. Let's give it a try. In the resource section of this lecture, I provide a link to the official site for ESLint. On this page, we're given an example of a command for installing ESLint into our project. Let's copy this command to our clipboard. Next, switch over to the command line. Paste and run the command. Vite does not provide support for ESLint. This is one of the instances where a package is not automatically installed or configured for a project. We must manually integrate ESLint into our workflow. Luckily, it's really easy. Vite is easy to extend. In the command line, run the following command: npm install vite plugin eslint save dev. This package will instruct Vite to run our JavaScript code through ESLint for code quality. While not necessary, it'll be easier to use this plugin. Next, in the root directory of the project, create a file called vite.config.js. This file can contain the configuration settings for Vite. The name is very important. Otherwise, Vite will ignore our settings. Creating this file is optional. If this file does not exist, Vite will stick to its original configuration. In our case, we're trying to add support for ESLint, which is not part of the default configuration. In this file, we must export an object. Inside this object, we can add a list of settings. While exporting an object is not a bad thing, there's an easier way to configure Vite. I'm going to add a property called plugins. As I do so, I don't receive help from the editor for correctly spelling this property. What if I make a typo? It does happen from time to time. We should try our best to avoid wasting time. Vite has a function for helping us with code completion. At the top of the file, import a function called defineConfig from the Vite package. Next, we can wrap the object with this function. This function will return the object passed into it. Seems redundant, but it does offer code completion. Let's try typing the plugins property again. This time, the editor will be more helpful with the property name. It'll offer to complete the line of code for us. It's a simple workaround, but you can never be too careful. I prefer to use this function to avoid errors. Let's set this property to an array. In this array, we can start adding plugins from other packages. Before uploading this array, we must import the ESLint package. At the top of the file, import the ESLint function from the Vite plugin ESLint package. Next, call the ESLint function from within the array. That's all there is to it. ESLint will check our code during development. Let's switch over to the command line. In the command line, start the server with the npm run dev command. The command line is going to throw an error. This is to be expected. We installed ESLint, but we haven't configured it. ESLint will search for a configuration file from within our project's directory. In the next lecture, let's work on configuring ESLint with our project. In this lecture, we are going to configure ESLint with our project. We took the first step by installing ESLint. The next step is to configure ESLint directly. Keep in mind, ESLint is a separate package from Vite. This package requires a separate file for configuration. There are various ways to configure ESLint. We can add the settings directly to the package file. Alternatively, we can create a separate file. I prefer to create a separate file. This reduces clutter in the package file. It'll be easier to focus on ESLint by using a separate file. In our project's root directory, create a file called .eslint.rc. Inside this file, we'll input an empty object. This object should contain your settings. In this object, add another object called rules. In the resource section of this lecture, I provide a link to an official list of rules in ESLint. We have the option of picking and choosing which rules should apply to our codebase. We're not forced to use everything at once. ESLint does a great job of providing a description for each rule. If you need more info, you can click on a rule for code examples. For this demonstration, we are going to enable a rule for enforcing double quotes. Head back to the editor. In the rules object, add a property called quotes. This rule will enforce double quotes. The value for this property can be one of three values. We can set this rule to off to prevent the rule from being applied to our codebase. This is the default value for most rules. The second possible value is warn. ESLint can cause our project not to be built. The warn value will allow errors to go through, but will display the problem in the console. The last possible value is error. Unlike the warn value, the error value will not allow our project to be built. We must address the issues thrown by ESLint before building our project. Let's set this rule to error. The rule is ready. However, we're not finished yet. Below the rules object, add an object called environment. There are dozens of environments JavaScript can run in. ESLint doesn't assume which environment our code will run in. We can specify the environment through this object. In our case, our app runs in the browser. This property will be set to an object of environment we can turn on or off. Add the browser environment and set it to true. By enabling this environment, ESLint will not throw errors related to the browser. Next, add an object called parser options. In our script, we're using import statements. We must add explicit support for ES6 import statements by configuring the parser. In this object, add a property called ECMA version. This property's value should be the version of JavaScript. Set the version to 2022. Next, add the source type property. This property's value should be set to module to support import statements. Our configuration is ready. The next step is to start the server. If you have it running, you will need to start it. The configuration settings will not take effect until the server has been restarted. In the command line, run the npm run dev command. After a few moments, an error will get produced by Vite. The error stems from the code quality check by ESLint. As you can see, the error informs us of the file name and line numbers. In addition, a description is given for each error. In the main.js file, we have strings created with single quotes. Let's open this file. While it's great that ESLint caught these errors, we have one problem with the presentation of the errors. We must constantly switch to the console to check for errors. It would be great if the editor could point these errors out from the file. Fortunately, there's an extension for adding this feature. Switch over to the Extensions tab for Visual Studio Code. In the search box, search for an extension called ESLint. This extension is managed by Microsoft. Let's install this extension. You may need to restart your editor after installation. I'm going to quickly do so. After enabling this extension, red lines will appear under our code. We can hover our mouse over these errors to inspect them. As you can see, we can read errors directly from the file. We do not need to switch to the console to discover errors. That's great. The question becomes, how can we fix this error? There are two options. Firstly, we can manually fix these problems. But what if we had dozens of errors? It would be a nightmare to fix our issues. The second solution is to allow ESLint to fix our errors. Open the package file. Under the scripts object, add a new command called lint with the following value: ESLint main.js fix. The ESLint command is available from the ESLint package. This package will perform the linting process. If you want to use ESLint without tying it to a specific tool, you can use this command. After this command, we must specify a file to lint. Lastly, we're chaining a flag called fix. By default, ESLint will only output errors. However, we can force ESLint to fix any errors found by it. Fixing errors is not always guaranteed. If it fails to fix an error, you may need to manually fix the error. Let's try running the command. In the command line, run the npm run lint command. After a few moments, the file should have been updated. If you switch to the main.js file, the errors have gone away. ESLint swapped the single quotes with double quotes. Awesome! We've successfully fixed the problems with our file. Technically, single quotes do not produce errors, but we are enforcing a standard in our project. Overall, ESLint is a powerful tool for checking the quality of our code. We've only scratched the surface. As we dive into Vue, it'll help us catch basic problems, such as unused variables or import statements. Let's continue exploring tools in the next lecture. In this lecture, we are going to get a brief overview of Webpack. Throughout this section, we've dedicated our time to learning about Vite. Vite is going to be our primary choice of a module bundler. However, you may encounter Webpack during your career as a developer. This lecture will give a quick overview of what Webpack is and how it works. In the resource section of this lecture, I provide a zip file. Download this file, unzip the contents, and point your editor to the directory with the files. I recommend uploading these files to an empty directory. Pause the video if you need. Once you're ready, let's try installing the dependencies. Open the command line. Let's run the npm install command. While the packages are being installed, let's explore the files. The script and CSS files are copies of the files from the Vite project. The project I've provided will output the same behavior as the previous project. However, these files are bundled with Webpack instead of Vite. Let's open the webpack.config.js file. Unlike the Vite configuration file, there are dozens of lines of code. Webpack is more hands-on than Vite. As far as Webpack is concerned, only JavaScript code is supported. Support for other languages like CSS or Sass is not supported. Every tool must be configured in the bundling process. For this reason, Webpack has a higher learning curve. To save time, I've provided the configuration code for you. Let's review it together. During the bundling process, Webpack will search for this file. If this file exists in our project, it'll apply the settings exported by the file. There are 4 properties that can be configured. The first property is the entry point. Previously, Vite configured the entry point as the HTML file. For Webpack, we must set the entry point to a JavaScript file. The entry property allows us to specify the entry point of our application. In this example, we're passing in a relative path to the index.js file. Up next, we have a property called output. In addition to setting the entry point, we must tell Webpack where to save the bundle. In this object, there are 2 properties called path and file name. The path property should point to the directory. The value must be a full system path. To help us generate a full path, we're using a constant called directory name to point to the current project directory. This constant is defined by node. Afterward, we're appending a relative directory called distribution. This directory doesn't exist, but that's okay. Webpack will create it for us during the building process. As for the file name property, we can set the name of the file produced by Webpack. In this example, we're setting the name to bundle.js. Let's move on to the modules.rules property. As I mentioned before, Webpack supports JavaScript. Other languages or file types are not supported. We must add explicit support for other types of files. Loaders are packages that will help us support different files. In this example, we're adding support for 2 types of files, JavaScript and CSS. Each object in this array can represent a file type. In the first object, we're adding support for JavaScript. Hold on a moment. Didn't I say Webpack supported JavaScript? Well, that's true. The support may be lackluster. New versions of JavaScript are released annually. You may want to start using newer features from the language. However, these features may not be available in the browser. There's a package called Babel. This package adds support for new and experimental features in JavaScript. Oftentimes, developers will integrate Babel with Webpack. This is why I've included this object. This object has three properties. The first property is called test. Before a file is given to a tool, Webpack will test the file name against this property. Babel does not process CSS or image files. To avoid Babel from processing the wrong file, we can test the file name. The value for this property is a regular expression. It'll check the name for a JS extension. If this extension exists on the file, Babel will process the code. Up next, we have a property called exclude. It's not uncommon to import code from packages in the Node Modules directory into our project. There are thousands of files within this directory. To speed up the bundling process, we'll skip files in this directory. They should already be optimized for the browser or Node. Lastly, we have a property called use. This property can be set to the name of the package that contains a loader for processing a file. In this case, we're using the Babel loader package to process JavaScript code. Let's scroll to the second object. The properties are going to be similar. The second object is testing for a SAS file. There is no exclude property. It's completely optional to add it in. Lastly, the use property is set to an array. We're not forced to apply a single loader. We can apply multiple loaders. In this example, we're applying loaders for SAS, CSS, and post-CSS. There is an additional loader called mini-CSS. By default, Webpack will bundle our CSS and JavaScript into a single file. However, that's not ideal. We may want to separate both languages into their respective files. The mini-CSS loader will handle extracting CSS from a JavaScript file. This loader can be configured through a plugin. Below the modules object, we have an array called plugins. Within this array, we can add plugins for extending Webpack with additional behavior. In this example, the mini-CSS package is being configured by setting the file name of the CSS file. The last setting in our file is the watch property. By default, Webpack will build your project once. However, you may want Webpack to constantly watch your files for changes. Setting the watch property to true will enable this behavior. I know I flew through the configuration. This lecture was meant to give an overview. We're not going to be using Webpack. I included this lecture for those of you who are curious as to what the hype is about for Webpack. Let's try running Webpack. In the command line, run the following command: npm run start. In a few seconds, Webpack will watch our project. We can update our code for a new bundle to be produced. The bundle will be created in the distribution directory. If we look inside this directory, we're going to find the JavaScript and CSS code. There are some things missing from the Vite project. For example, an HTML file is not available. We don't have a server for previewing a project. It is possible to generate a server, but I wanted to keep this lecture brief. For that reason, I only included support for JavaScript and CSS files. In addition, ESLint is not checking the quality of our code. Webpack can support additional tools. Feel free to add support for these features. Anyway, that about does it. In the next lecture, let's wrap things up. I'll see you there. Congrats! You've made it to the very end of this section. We've only gone over the basics of each tool and its concepts, but it should be enough for you to tackle complex Vue projects confidently. For the rest of this course, we're going to use Vite. There are other tools Vue uses internally than the ones I talked about in this section. We'll review them as they arise, but the ones I mentioned in this section are the primary tools you'll most likely be dealing with from within your project. As always, I encourage you to continue your studies in each of these tools and libraries to make you into a better Vue developer. Now that we have an overview of things, let's get back into Vue. It's time to start developing applications. I hope to see you there.